Hi everybody, today's lesson is 2.7 Curve Fitting with Linear Models. And the objectives for today is you're going to be able to fit scatter plot data using linear models with and without technology. You're also going to be able to use linear models to make predictions. And so problems similar to these can be found on page 142 through 145 in your Algebra 2 textbook. So let's get started. All right, let's talk about what a scatter plot is. These problems are a little bit different than what we've been used to. So today's lessons, instead of having um, just one straight line, we have several points that have just been plotted. And as you can see, there's a scatter plot is helpful in understanding the form, direction, and strength of the relationship between two variables. Correlation is the strength and direction of the linear relationship between the two variables. So let's look at the first graph. The first graph shows us what is called a positive correlation. And the reason it's positive is simply because it tends to be going up like the slope would be in a positive direction. So we call that a positive correlation. The positive is just telling us that it's going up. When we look at this next one, you see that it tends to be going down like a negative slope, and so that's called a negative correlation. And it's called a correlation because it kind of is close. You can kind of looks like it's a bit of a line. It seems to be going up, and this one seems to be going down. But when you look at this one, there's really no correlation at all. So that's a relatively no correlation. Okay, so if there's a strong linear relationship between two variables, a line of best fit or a line that best fits the data can be used to make predictions. And when we are drawing our line of best fit, you want to try and have about the same number of points above and below the line of best fit. All right, so let's take a look at an example. It says Albany and Sydney are about the same distance from the equator. Make a scatter plot with Albany's temperature as the independent variable. So that means Albany is going to be our x and Sydney will be our y. And here's our points that we'll plot: 3165, 3466. Those are the points that we'll plot. All right, so after we plot them, we're going to look at if there's any kind of correlation and name the type of correlation. Then we're going to sketch a line of best fit to find its equation. Okay, so here I've let the computer plot it for us. So here's all of our different plots. And as we look at that, we can kind of see that there's a negative looking slope. So this looks like it's a negative correlation. All right. So once we look at that and identify that there's a negative correlation, we can actually draw a line in, sketch a line in to see. And here's a line, and you can see that some of the points are on either side. I tried to keep it about equal there. So draw a line that splits them. All right, so the next thing we want to do is identify 2 points, because the next thing it said was to come up with an equation for this line. So if we came up with an equation for this line, we need to choose 2 points on there so we have some points. So let's choose a couple. Let's try 80, and let's see, that looks to be about 42. So this is going to be 80, 42. And let's look at another point. Let's just pick this one. It looks like 10, and then it seems to be going to, let's see, no, maybe 75. Let's say 1075. 1075. All right, so now that you have 2 points, you've learned in the other lessons how to write an equation of a line with 2 points given. So we'll just use the slope-intercept first, y1 minus y2. Here it is. This is our x1, y1, x2, y2. So we're going to say 75 minus 42. Sorry, I'm doing this on a weird screen today. Divided by 10 minus 80. 75 minus 42 is 33. 10 minus 80 is a negative 70. When we divide that out, we get negative 0.47. Okay, so that's our m. All right, so we have y equals mx plus b. So now we could just say y. Let's choose this one. I like the smaller numbers. Y is 75 equals M, which is negative 0.47 times our X, which is 10, plus B, which we don't know yet. Okay, so let's see, plus B. All right, so 47 times 10 is a negative 4.7 plus B equals 75. So let's add a positive 4.7. 4.7 to both sides. 4.7. And that will give us 797 equals B. So our equation for this set is going to be y equals negative, sorry, I don't know why I do that, negative 0.47 plus our B, which is 79.7. All right, now, oh, goodness, I'm X plus 79.7. So there's our equation. And I want to point out that this is not actually equal. This is going to be, we're going to use this little formula that looks like that. It just tells us it's approximately. It's pretty close because our line is a straight line, but all of our points aren't exactly on the straight line. Okay, so let's keep moving. All right. So once again, it says to make a scatter plot for this set of data, identify the correlation, sketch a line of best fit, and find its equation. So I'm going to, again, these are going to be our x's, and these will be our y's. So we're going to plot 28, 16, 35, and so forth. So I'm going to let the computer do that for us. Here they go. And as we look at that, as we look to identify our correlation, we can see that it seems to be going in a positive direction with a positive slope, and it does look like there's some type of a correlation. So I would say there's a positive correlation. And so there are, you can see that the more time goes by, the points get higher. All right, the next thing we want to do is sketch a line that's a little bit between, has some on the one side and some on the other side of our line. And so there's a line that splits the data evenly above and below. All right, so the next thing we want to do again is we probably need to come up with 2 points so we can write an equation for this line. Let's choose 2010. That seems to be a pretty good one. And how about 4025? Let's do that. So we're going to use 2010 and, oh my goodness, 2010 and 4025. So I've written that down on our next page here. All right, so this is our x1, y1, x2, y2. All right, so let's do our problem. We have 25 minus 10 over 40 minus 20 equals 15 over 20. 5 goes into that 3 times, 5 goes into that 4 times, so that equals 0.75. All right, so that's our M. So now we have, let's choose 20 and 10. So we say 20 equals our slope, which is 0.75 times X, which is, oh, hold on. Let's fix this. This should be a Y because our equation is Y equals MX plus B. So our y is going to be 10 equals 70 times our x, which is 20, plus b, which we don't know. 0.75 times 20 is actually 15, plus b equals 10. So let's subtract 15 from both sides. We get negative 5 equals b. So the equation is going to be y equals 0.75x plus a negative 5, or you could say minus 5. And again, let me remind you, it's not equal though. it's approximately equal. So make sure that you go back and get your approximately equal in. Okay, so now when we see these points, there's a thing called a correlation coefficient R, and it's a measure of how well the data set is fit by a model. Okay, so R is going to be somewhere bigger than -1 and smaller than +1. All right, so let me tell you what each of the R's mean. When R equals 1, a total whole 1, that means the data set forms a straight line with a positive slope, okay? So it's going to be totally a straight line. All your dots are going to be right on the line. All right, if it's 0, that means the data has no correlation. And here's a sample of 0. There's just no order to it at all. It doesn't look like it's up or down or anything. And if it's a -1, that means the data set forms a straight line with a negative slope. And so all the dots are exactly on the line. All right, if it's a totally a -1. And let me just point out to you that this is not a slope, but it does use this negative and positive to tell us which way the information is going. And so in this case, it's going in a negative slope, so it gets a negative. And I think of this as this number, the closer it gets to 1 or -1, the more tightly this information is wrapped right around our line of best fit. Okay, so this is 0.95, and I kind of think of that as like 95%. That's pretty accurate. All right, now when you look at this one, again, it kind of looks like it's got a negative slope, but so we put a negative with it, and it's not that close to the line of best fit. You got some points that are pretty far away from the line. So our R in this case is 0.6. Here, as I said, there's really no correlation. This one, it kind of looks like things are trending upward a little bit, so we'd say that has a positive correlation. But they're not really tightly next to one single line, so our R in this case is 0.6. And finally, this one clearly looks like it's pretty tight and accurate, and so our R is 0.95 and it's positive. So again, this is just a measure of the data, how well it's organized and how well it fits the model. And again, don't get it confused with slope. The only reason we're using negative and positive is just to tell whether the slope is going in a downward direction or an upward direction. And that's what makes it the correlation coefficient R. If it's negative, it's going in a downward slope, and if it's positive, it's going in an upward slope. All right, let's move on from there. All right, you're going to be using your calculator now to do these. I think you'll find it a lot easier. I'm going to show you one of the things we want to make sure that we have on your calculator is this diagnostic on button. And so I'm going to escape through here and pull my calculator up real quick so you can see that. So what you want to do, turn your calculator on, and what you want to do is come to this second button here. Let's see, let me clear this out. Okay, clear again. Let's see. I'm going to go to this button that says second and go to catalog. And once you go to catalog, we want to just skim down here all the way. You can go pretty fast on this and get to dialog or diagnostic and see where it says diagnostic on. You want to hit enter there and then hit enter again and it'll say done. And that way you know that you're ready. And if it doesn't come up, go back to this step. Go to second catalog and try it again. Okay, so let's just move on for just a minute. Okay, so we're going to have some information. I'm going to keep this page up. We're going to have some information. This says anthropologists can use the femur or thigh bone to estimate the height of a human being. The table shows the result of a randomly selected sample. Okay, so what we're going to do on this problem is we want to first just make a scatter plot of all this information. So this is our X. The length is our x and the height is our y, and we just plot that on. And I'm just going to go ahead and show you in the interest of time, plotting each of those points on here and then drawing our line. You can see the scatter plot. Okay, so now the next question says to find the correlation coefficient R and line of best fit. Okay, so I'm going to show you how to do this with our calculator instead. So what we're going to do is you're going to get your calculator out, and if you need to put your video on pause and go get your calculator, that would be a really great idea. Okay, so what we're going to do is we're going to start out and we're going to go to Stat. Okay, so here's the Stat button, and we want to go to Edit and come down here and enter and edit. And we're going to have L1 and L2 and L3 and different things, all right? So our L1, we're going to let that be our x's. So what we're going to do is you're going to type in each of these x's over here into your calculator. So I'm going to do it with you, and you can do it. You can put your calculator on pause if you need to, or not your calculator, your video on pause while you get these all in here. So you put in 36 and then press the enter button. And then 32, enter, and so forth till you get them all in. Let me get that in real quick. 38, 30, and 27. Okay. And then L2 is going to be your y's. Okay. So we're going to put our y's into L2. So 160, and you push enter each time to get it in. 143. Enter, 187, 142, 161, 164, 140, and 131. Enter. Okay, so once you have them all in, then we're going to come back to this button here that says Stat. Okay, so you click on your Stat, and this time we're going to scooch over one to Calc. So go to your arrow here and push over to Calc. Okay, once you're in Calc, you want to use your down arrow and take us to number 4, which says linear regression is what that stands for, linear regression. And that just means it's not going to be, you're not plotting exact points. You've got two pieces of information, like we have length and height, and they're not necessarily going to give us an exact function or an exact straight linear line. So it's a linear regression. Okay, so once we get to linear regression number 4, we're going to click enter, and you can see that my x is in that L1 that I had, and my y is L2. And I'm just going to come all the way down here to where it says calculate, and I'm going to click enter. All right, and once I click enter, I'm going to get a bunch of information here. And this information is really helpful to us because you can see it's in y equals ax plus b, which is going to be equivalent to our mx plus b. So our a is going to be our slope, and our b is our y-intercept. All right, so let's just see how that would write out. So you would say y, oh, lost my calculator. I don't think I can do it with my calculator on here. All right, I can't. But I can pull this page up here. Okay, so here's a copy of it over here. So our line of best fit, the equation of line of best fit, you don't have to do any of that y1 and y2 subtracting and all that. You can just put it in your calculator, and here we see y equals, and here they call it L, H and L for height and length, but it doesn't matter your variables. But here's our 2.91, that's the A, that's our slope, okay? And so then we have our B plus B is 54.4, and that goes right here. So that's what we need to do. That's how you do it. Okay, so let's talk about this r. We don't need to worry about this r squared, but we do want to look at this r here. It says our correlation coefficient r is 0.98. So that tells us, which we saw before up here, that our points are really close to our line of best fit. So it's pretty accurate. All right, so we could take this information here and take our information, and we could see what a man's femur, if it is 41 centimeters long, we could predict his height by using our equation that we just found. Here's our equation. H equals 2.91 plus 54.04. That's the equation to predict the man's height. So it says if his femur is 41 centimeters long, we just put that in our X. And when we substitute and do the algebra, we come up with H equals 173.35. So our conclusion is the height of a man with a 41 centimeter long femur would be about 173 centimeters tall. Okay, so here's another example. I want to do this one with you so you can once again get this in your calculator. I want to make sure that you know how to use your calculator on these problems. So again, we're going to come back to Stat. We're going to go to Edit and Enter. All right, I'm going to go ahead and clear out. Actually, I'm not going to because I've already done these problems over here at 3L and my L3 and L4. So I've already inputted all this information. If you'd like to turn your computer off or your video off for a few minutes and put it in your own calculator, that's fine. I've already done it for us, but I want you to see what to do once you get that in. Again, we go back to Stat. This time we're going to move over to Calc. Okay, so I'm going to go to the Calc, and I'm going to go down to 4, Linear Regression. So come down to 4 where it says linear regression, enter. All right, so this time I didn't use L1 and L2. I actually used L3 and L4. So I'm going to say second, and here is my L3 right there. So I'm going to click that, and it'll say L3. And then I'm going to come down to this one, and I'm going to say second, and I'm going to put in that for L4. So my X is going to be the things that I put in for L3. My Y is for things that I put in for L4. I'm going to come on down here, and I'm going to calculate, enter. And here, once again, I have my slope of negative 0.149 or 0.15, and here's my y-intercept, and my r is 0.916, and that's still a pretty close correlation there. So once you have this information, you can write your equation into the y equals mx plus b form, and you can answer questions. So if they ask you a question about the horsepower, you would fill in with an X, and if they ask you about mileage, you would fill into the Y. All right, so let's go on. And here's the scatter plot of that information. You can see we already found out that it was a negative slope, but the correlation shows that it is, and it is pretty tight. So you can see that 91 was pretty high, but it's a negative because it's in a negative slope. All right. All right, so we've already done this. There it is again. There it is again. Okay, so predict the gas mileage for a 210 horsepower engine. So that means the horsepower, so we know it's going to be 210. So the horsepower was our X. So we get our equation again. I'm going to pull it back up here. Y equals this. And since the horsepower was our X, we're just going to fill in 210 into our X here. All right, and when you multiply through that all, you end up getting y equals 16. So our mileage is going to be 16 miles per gallon. And there it is. All right, one more. I want you to work on it. Just really want to make sure that you can get these into your calculator just fine. So let's pull our calculator up one more time. We're going to go, no, I don't want a second. I'm just going to go back to Stat again. Go to Edit, Enter, and let's see. I'll go back to 1 again. So I'm going to go all the way back using this back arrow to 1. I'm going to start deleting everything in there. I'm going to go to 2, delete everything in there. Notice I'm pushing the delete button. All right, I'm going to go back to 1 and enter these points, and you should do this also. 29, 30, 39, 48, 58, 68, 73, and 72. Enter. All right, so there were 9 of those. Now I'm going to come over to my L2. My temperature, I'm going to make this the X, and my rainfall as the Y. So now I'm going to do my Y's, which is going to be 95, 91, 100, 93, 84, 79, 73, and 92. Enter. Okay, so there's my things. All right, so I've entered in my information. I'm going to come back to Stat. I'm going to go to Calc. I'm going to come down to Linear Regression on 4. I'm going to hit Enter. All right, now I'm back to L1 again. Yours is probably already set for L1. If you need to change it, you can. That's what I need to do. So I'm going to go back to L1 for my X's. My X's in list L1. And then I'm going to come down, and my Y's I put in L2, so I'm going to second down to L2. Now I'm going to come on down all the way and calculate, enter, and here's our calculations. And we'll look at our plotted points in just a second and see that it's a negative slope. And notice that my regression is a negative 0.70, so it looks like that's going to not be very close. That looks like the points are going to be kind of spread apart. So let's take a look at that, the rest of that. So I hope you're able to figure out how to use your calculator like that. All right, let's see, next. So here's all of our points, and you see they're not quite as close together as they were before. So, and notice that it is in a negative, got a negative slope, so that means it's got a negative correlation coefficient. So here's the numbers that we just got, and now you can write your equation out. R equals negative 0.703. And there's our equation. And notice that we use the squiggly equal sign because it's not exactly equal, just kind of close. But it's a lot easier, I think, than having to write all the points out and do the y1 minus y, or y2 minus y1, all that information. Okay, so you could predict if there was the temperature, if there was 80 of, you can predict the temperature when the rainfall is 86 millimeters, and how accurate do you think your prediction is? So we can see that it would, you know, it's 0.7, it's kind of all over the place. It might not be a really good prediction. All right, but in order to predict that, it says let's go back to that question. It says, predict the temperature when the rainfall. So we're given the rainfall. So let's look back up here. The rainfall is our Y. Okay, so we're going to put the rainfall number in here for your Y and then solve for X because we're trying to predict what the temperature is going to be. All right, so if it's 86, here's your, I've already done this all out for you. So here's our 86, it's the Y. Okay, we're solving for X, and we end up with 58.3. And so it says the line 58.3, but the scatter plot and the value R show that temperature by itself is not an accurate predictor of rainfall, because that 0.70 is not very accurate. You want it to be closer to the 90s. Okay, so a line of best fit may also be referred to as a trend line. All right, and one more problem, and I'm going to let you do this one on your own, and I'm not going to actually do all the inputting in the calculator with you this time. I'm going to just let you do that. So put your video on pause for a minute, and you can try and get that in. Okay, so There's a lot of different things they want us to do today on this problem. It says find the following information for this data set on the number of grams of fat and the number of calories in sandwiches served at Dave's Deli. Use the equation of the line of best fit to predict the number of grams of fat in a sandwich with 420 calories. And then it says how close is your answer to the value given in the table. So assuming that you put in all your information in your calculator, you would have drawn a scatter plot, and as you can see, there is some correlation, but it's not very close to that line, so it's not very accurate. So once we've done that, then you can put your information in your calculator. You end up with an R equals 0.68, so that's really not that high. And here's the equation of the best line of best fit. Again, it's approximate. All right, and going back just a second, the question said, let's see, use the equation of the line to best fit to predict the number of grams of fat in a sandwich with 420 calories. So notice that our fat was the X and the calorie was the Y. So we're going to go put this 420 in our Y in our equation, put it in where the Y goes. So this is going to be 420 here, and we'll need to solve for X. So putting in 420 and solving for X, we get 9.9. So the line predicts 10 grams of fat. So when we look back at the table, one more time, our table, 420, it actually was 15, but when we put it into our equation, which it was just a guess of an equation, it's approximation, it's not that close because we came up with 10. Okay, so that is the end of your lesson today. And your Bible verse is one of my favorites. I have not commanded you, have I not commanded you, be strong and courageous. Do not be afraid. Do not be discouraged, for the Lord your God will be with you wherever you go. And I just really want to point out, do not be discouraged. This can be really, really hard, but we're going to work through it. All right, you guys have a great day. See you soon. Bye.